Now, I noticed a strange thing happening with our simulation here. If you notice it moving along, some of the coffee beans are just kind of freezing in place. See there, they've stopped. Some of them have stopped. The slower particles have, the slower coffee beans have stopped. So the reason that is that they're going to sleep, right? We have this kind of sleep thing here. You can see they're being deactivated. If I turn on the guide geometry, so these are active objects and these are deactivated objects. You can see the red ones have stopped. So again, I'll hide that visualizer. If I turn off the sleeping time, set it to 0. I'm just going to turn off this implicit drag as well, as we don't want any drag in this sim. Play it again and it should play through without any problems. There we go. Seems to be fine now. And then we're getting the beans colliding with each other. So what I'd also like to do is add some spin to these. Okay, so what we can use, so this is a rigid body simulation. However, as they're packed objects, really is just points. So when we're talking about forces, you can see each of these is just a point, and we can add forces to those points. So whether you've worked in with particles in Houdini before, I'm not sure, but it's known as pop in Houdini, and anything pop is related to particles. But a lot of the pop stuff we can use for with bullet also. So we're going to use pop spin to add some spin to our particles. Okay, and they go into the last input here, post solve. So apply the force after everything, all the other collisions have been resolved. Let's put this back to the normal visualizer, turn off this. I'm going to change the axis a bit just so it's not facing up, so, you know, just so it's a bit different. And let's give it a spin speed of, I don't know, let's give it something really high just so we can see if it's working. And press play. And hopefully they should spin. There we go. You can see them spinning there, which is again another layer of detail, more interesting, more realistic. But they're all, this force is applied equally to all of them. Okay, and I don't want that. So if you notice here it says vex expression, we can write some vex to write a apply a different force to each object. So I'm going to change this back to 100. So here we want to work on this spin speed. We're going to write values to the spin speed. So the name of this attribute is spin speed. You can see their parameter spin speed. So spin speed, we need to write it like this. This is the label. We need the parameter name. So we're going to write to, oops, not plus, we're going to write to this, and we need a random number again, based on, so each point here will have a different point number, so we can use at to access an attribute, and we're going to use pt_num. which is point number. So each one will have a different point number, and again we need a different seed for the rand functions for them all to be different. Okay, and that should give us a different number. However, if you remember, this will give us a number between 0 and 1, and we a moment ago had a value there of 500, I think, I can't remember, and they were just spinning. So, you know, a spin speed of 1, you're not going to see that. So to rearrange these values, again, we're going to use the fit function. So you can see there we're using the same functions. Again, they're very common things to do in Houdini, and a good thing to have in your arsenal. Okay, so I'm going to do this between 50 and let's do 200. Okay, so, oops. So to end a vex, a line of vex, we need a semicolon. We've got the two functions there. So this function takes the rand function as it's one of the arguments. Okay, and let's see what that does. There we go. Great. A bit more subtle. We got a couple of particles which are spinning a bit faster. Some which aren't really spinning at all. It's a bit more organic. Just better. Okay, great.